Before we start our exercise, and this will be our topology, let's calculate the summary address first. Obviously, we'll want to summarize these networks here, the ones inside area 0. To do that, let's list all of those networks' third octets in binary. Networks 10, 0, 96, third octet is obviously 96, and in binary, this is what it looks like. 97 is this, 98 is this, and so on. These are the rest of the networks. Now, what we want to do here is we want to figure out the number of bits to the left, which are the same in each of these subnets. Obviously, from here to the left, all the bits in all of listed subnets match. Then we'll take those matching bits and copy them, and to the right of our red line, we'll write in zeros. Remember, this is our third octet, so we should add zeros to our fourth octet as well. When we turn these binary numbers back to decimal numbers, we get our summary IP. The mask, by the way, /21, is the exact number of bits left to the red line. That's the number of bits that don't change and that are the same in every subnet. Now, that was the calculation part. How do we configure it in OSPF? This is how. On the area border routers, in this case, routers B and I, we say area 0, and this is the area in which all the subnets are summarized. Range, this means inside this range are all the summarized IPs, and then we state the summary IP using the regular mask, even though we're in OSPF configuration mode, so we have to say router OSPF and then OSPF ID to get here. We don't use the wildcard mask for this. Yeah, that's it. Let's do it in Packet Tracer now. In this Packet Tracer file, everything is already configured, even OSPF. So what is left for us to do is to advertise only the summary IP. First, let's look at router A's routing table just for comparison's sake. So let's see what it's like before we advertise the summary IP. Enable show IP route. And we can see all of these different subnets here. So if we compare that to our topology, we can confirm that we see pretty much all of the subnets that we see in here. Then let's try to ping just to make sure that connectivity works. Okay, everything seems to be working. Let's configure the summary route. Again, we configure this on area border routers, so we're pretty much telling to the other routers, so the routers outside of area 0, to use the summary IP instead of remembering all of these specific subnets. All right, enable configure terminal router OSPF. I used 1 as OSPF process ID, and then we're going to say area 0 range, and our summary IP is 10.0.96.0, and the mask was /21, right? Yeah, so /21, it's this mask, 255.255.248.0. That's it for router B. We can go to router I now and use pretty much the same command. So enable configure terminal router OSPF 1 area 0 range 10, 0, 96, 0, 255, 255, 248, 0. I'm going to press fast forward to make sure that all the OSPF routers communicate this new information to each other. And then let's go to router A. So this was the routing table on router A before we configured the summary route. Now I'm just going to use the up arrow to repeat the previous command, which was show IP route. And this time we can see that the routing table is significantly smaller than previously. We can see this network 1000, that's the directly connected network, 2000, which is this remote network over here. And then we can see the summary IP, sorry, that's this one, that represents all of these networks that were previously listed separately up here. And that's pretty much it. Let's test the connectivity to make sure everything is working. It is perfect.